This video will be about triangle congruence. So when we say the word congruent, congruent means two shapes that are exactly the same. So the same shapes. They can have been moved around, but they have to match exactly, even if they've been moved around. So if I have that rectangle there, and then this rectangle here, now I drew these freehand, so they may not match exactly, but pretend that's my drawing skills and not whether they actually match or not. If I moved this around, I'd have to rotate it as well. They match. That's pretty good. Mostly exactly. So congruent just means same shape. They're exactly the same. So with triangles, we spend a lot of time trying to prove if these two triangles are congruent. So let's say we have a triangle here. This time I'm just going to copy it so that we have the exact same triangle. So we want to prove, hey, are these two triangles the same? Just looking at them and seeing it is not enough. Yeah, they look pretty close, but that's no guarantee that they're exactly the same. So we need some more information. Well, if I put that mark there, that mark means those two sides match each other. So now I can say those two sides are the same. Let's give these triangles some names so we can work with them. So with that one marking, I can say, okay, side AB, well, that's the same, which we use the congruent symbol since we're talking about a shape, as side DE. Well, let's do another mark. Let's say I mark BC is the same as EF. So now I can say those are the same. BC is congruent to EF. And one more. Let's mark this side the same, so we can say AC is the same as DF. Well, we might be able to say, oh, all the sides match. That must mean everything's congruent, but we don't know that for sure yet. What about all the angles? We also have to mark the angles and see if those match. The only way this is congruent is if all the sides are the same and all the angles are the same. So if I put that little kind of circle thing, then that's saying angle A is congruent to angle D. If I put two marks, then angle B would be congruent to angle E. And if I put three marks, then angle C would be congruent to angle F. So I know all six sides are the same, all three sides are the same in all three angles, 6 items total, which is why I thought 6. All three sides are the same in all three angles. That means these two triangles are congruent. Triangle ABC is definitely the same as triangle DEF. But mathematicians usually kind of want to take a shortcut. They don't want to figure out all 6 sides and all three sides and all three angles. They want to use as little information as possible. This was overkill. All 3 sides, all 3 angles. So they figured out what's the least amount of information possible I need to show that these two triangles still match all 3 sides and all 3 angles. So they came up with some postulates. The triangle congruence theorem, they have side, side, side. Side, angle, side. And on this one, the angle must be between the two sides. They call that an included angle. Angle, side, angle. Again, this side here in the middle must be between the two angles. And then the last one is angle angle side. This time the side is not between. So this is again to make things easier. If I know all three sides are the same on two triangles, that means all three sides and all three angles are the same. Or if I know a side, an angle in between, and another side are the same as a second triangle, that means all three sides are the same and all three angles. It's the least amount of information we would need to know that all three sides match and all three angles match. Now there's two that don't work. Angle, angle, angle doesn't work. If I know all three angles match, that doesn't mean that all three sides match as well. And let me spell this properly. Work. And angle, side, side, I always remember that one because we don't want to swear in math. So angle, side, side also doesn't work. Just because you have an angle and two sides that match on both triangles doesn't mean that all the other information on the triangles match. So let's look at an example. Let me redraw that so it's a little closer. So looking at our two triangles, they've given us some marks to show us that things match. They said this side here matched this side, so CB matched ED because they put the one mark. And they put 2 marks from AC, so FE matches. They put 3 marks from D to F, so B to A matches. So they said that a side followed by a second side, followed by a third side, matched. Well, that's enough information to say, well, all the angles would match as well. I could say angle D matches angle B, and angle E matches angle C. All 3 angles match because those 3 sides matched. So these triangles are congruent. So triangle ABC is congruent. Now I have to go in a certain order. I started at A, went to B, went to C. A went through the 3 lines, B to C went through the 1 line. So we have to go in the same order. I have to go through the 3 lines first, and then be able to go through the 1 line. So I have to start at F to go through the 3 lines, and then go from D to E to go through the 1 line. So this would be F, D, E. So those 2 triangles are congruent by side, side, side. Now sometimes there's some information that they want you to assume. It's easy if they just mark it all for you. Sometimes they don't mark everything for you. Sometimes there's some information you have to assume. Again, let me label this WXYZ. So looking at this, they did mark some information for us. They said, okay, this side matches this side. They gave us an angle that matched, so those angles matched. And then there's a piece of information they assume you know because of the way the picture is drawn. Anytime that there is a line used for both triangles, that line XZ is used for the left triangle and it's used for the right triangle. It's the same line that's been used for both triangles, then you can assume it's the same. It also has a matching. So this is another side. So we have a side, we went to an angle in between the 2 sides we've colored in, and another side. So this triangle, these two triangles would be congruent by side, angle, side. And if we wanted to say what triangles are congruent, the first one I just pick. So if I'm looking at this left triangle, let's say WZX. It really doesn't matter the order you pick the first one. As long as then on the second one you have to go in the same order. We went from W to Z, so we went through the one line and then through the middle line to get to X. So we have to go through the one line and then through the middle. So Y, X, Z. So now again, we're saying that those two triangles are exactly the same. If I looked at angle Y, I could say angle Y is congruent to angle W. Not triangle, sorry, angle. Those are the same. They're in the same spots. They're both attached to the one line that's been marked and the line that has no markings at all. So they're in the same spot, and because the two triangles are congruent, then they're the same angle. So we had two more, angle, side angle, and angle, angle, side. Again, they may have parts that you have to assume on this. Okay, so there's our two triangles. Again, we only have two markings. We have this side congruent to the side down here, so we have a side. This side here congruent to this side here, another side. And then they assume, again, you know the way this picture is drawn, that angles across from each other. So when you form an X of any sort with two lines, the angles across from each other are equal. So now we have some matching angles. So these two triangles would be congruent by side, angle, side. We only use the three sides and angles from one triangle. So triangle ABE would be congruent to triangle. So we went through 2, then 1. We have to go through 2, then 1. So D, B, C. So as I said, there's two other possibilities, angle, side angle, and angle, angle, side. So let's look at two last examples where you can see those two theorems. So again, this can be moved about any way we want. Doesn't have to be in the exact same orientation. This time, they're not connected in any way, so there's definitely nothing we have to assume. We just have to figure out what's been given to us. Well, they gave us an angle marking, and it does match on the other one. A side marking does match on the other one, and another angle marking. So we went from an angle, the side is in between the two angles, and then another angle. So angle, side, angle. There's a really small change to this you could do to make this angle, angle, side. Remember, there's just a small difference between whether the side is in between the angles or not. If I moved my side marking down here, then this is no longer angle, side, angle. Now we go from angle to another angle to a side. So this one would be angle, angle, side. And again, we could name the two triangles that are equal to each other. Y, W, X. Y had no angle marking. W had one mark on our angle, and X had two. So triangle YWX would be congruent, and we have to go in the same order. No angle marking is M. We went to one angle marking, so N, and then two angle markings, O. So triangle WYX is congruent to triangle MNO by angle, side, angle. Now on the second one, where I did angle, angle, side, that's still not going to change the order that you would name your triangle, as long as I had them labeled exactly the same. This should be a Y so that it matches up. YWX still goes from no angle mark to 1 to 2. So that means the second triangle still goes in the same order, MNO. Because Y had no angle markings, so it matches with M. W had one angle marking, so it matches with N. And X had two angle markings, so it matches with O that also had two angle markings. So you could name pieces that match just by looking at the triangle YWX congruent to triangle MNO, because the letters go in the same order on purpose. If I said angle W, well, I know automatically that matches with angle N because they're both in the middle. They're both the middle letter. Or if I said side XY, that goes from the last to the first letter, so we have to go in the same order, O to M. So the last thing that can happen is maybe they don't give you enough information to prove two triangles are congruent. I don't remember what example number I'm on, so I'm just going to say example. Okay, so looking at this, they gave us two sides that match. This matches to that side. This matches to this side. And we can assume that the angles in the middle match. Anytime you have two lines crossing, angles in the middle match. But if you look at what they've given you, they've given us an angle, a side, and another side. Now the angle is not between the two sides, so it has to go angle first and then the two sides because the angle wasn't in the middle of them. Well, we said that wasn't enough information, so these two triangles we can't prove if they're congruent or not. They may still be, we just can't prove it. They may be, they might not be. So that concludes our discussion on congruence and triangle congruence.